Section 5.4, Determinants and Cramer's Rule. We have one more method to look at for solving a system of linear equations. This is probably one of my favorite methods, and I think maybe you will like it also. And we have made it to the end of the semester, so this is our last section. Okay, on our first slide, we have a definition for the determinant of a 2x2 matrix. When you write a determinant, you have straight bars around the matrix rather than square brackets. So the straight bars indicate determinant. So we're going to start out with a 2x2 matrix, which you would use if you were solving a system that had two variables and two equations. And how it works is you always start in the upper left. Okay, maybe we should make a note of that. Start in the upper left. And then you are going to multiply diagonal. So you're going to multiply these two together. A1 times B2. Then the sign is minus. That's very important to remember. Okay, you have to write a minus sign. And then you're going to multiply the other diagonal. You're going to multiply A2 times B1 and then write the result here. So the product of the first diagonal starting on the left minus the product of the second diagonal. Now it's certainly very possible that that second number may be negative. So you might end up with minus a negative that would then turn into plus. So let me show you with some numbers how this works. It says evaluate the determinant. So you've got your straight bars there. We're going to put an equal sign. The determinant is always equal to just a single number in the end. Okay, so this is just a calculation. So we're going to start on the upper left and we're going to multiply 4 times negative 8, which would be negative 32. Then we're always going to write minus. Then we're going to multiply the other diagonal. 3 times negative 5 is a negative 15. You might want to put it in parentheses to separate the negative from the minus. So now we calculate, that stays negative 32, but let's write minus negative as plus 15. So now our signs are different. We subtract, which is 17, take the sign of the larger. So our answer, the determinant, is negative 17. Look at one that has some fractions in it, number 2 here. So if you need to, you could write it out. When you do your first multiplication, write the fractions out. 2/3 times 3/4. And then minus, and now you're going to go the other direction. And it's a negative times a positive again, so it's going to be a negative 1/2 times 1/3. Or you could put the 1/3 times the negative 1/2. It doesn't matter which order you write those in. Okay, so on the first multiplication, you can either multiply straight across and then simplify it, or you could simplify first. If you choose to simplify first, well, I'm going to do it the other way. I'm going to multiply straight across. That might be easier for you guys. So if we go straight across, we're going to get 6/12. And then I'm going to have minus a negative, because the result of this is negative, so we're going to go ahead and put plus. And then across the top would be 1, and 2 times 3 would be 6. Now, to combine fractions with addition, we need a common denominator. So we could get that a couple of different ways. We could turn this 6 into 12 by multiplying top and bottom by 2, and then we would have to simplify our answer. Or over here, this 6/12 could simplify already. Now if we put it in lowest terms, it would go to 1/2, but I really want its denominator to be 6, so I'm just going to divide by 2, which will make that 3/6. And now I can add it to my 1/6. 3 plus 1 will give me 4 on top. Keep the denominator. and then simplify our answer. Divide by 2 is going to make that 2/3. So 2/3 is our final answer there. And there's several different ways you could go about getting that. But just remember, the main formula is start on the upper left, multiply, subtract, and then multiply the other diagonal. Okay, so how are we going to use this to solve a system of equations? Now, I know it looks like there's a lot of information on this slide, but it's really not difficult. This is called Cramer's Rule. And so if we had a system of equations like this, the A's, B's, and C's are just numbers, then we would find 3 different determinants. We would start by finding D, and you would put the coefficients of X in the first column and the coefficients of Y in the second column, and then you would calculate. Then you're going to find dx, and when you find dx, that X is subscript, by the way. In the X column, okay, if this says X, in the X column, you're going to put the constants, okay? Constants go here. And then still the Y coefficients go in the second column. To find dy, the Y column, whatever that subscript is, the Y column then would take the constants, these numbers that are on the other side of the equal sign, and the first column would still be the X coefficients. And I'll show you with numbers here in just a moment. So after you've calculated all 3 determinants, you're going to find X and Y with these formulas. X is dx divided by d, and Y is dy divided by d. And you find those 2 values and write your answer as an ordered pair, just like we did when we solved by addition or substitution. So here's our first example. Let's see. So we're going to find D first. So we'll go ahead and call it D. Use an uppercase D. And we'll list the coefficients of X in a column, 5 and 3. Then the coefficients of Y, 4, -6. Make sure if it's minus, you get that negative there. And then just put straight bars around that. And then let's go ahead and calculate that. Depending on the room on your page, you can either go down or you can go across. So I'm going to go across so that I don't run out of room here. So I'm going to start in my upper left. 5 times -6 is -30. Minus, and then the other diagonal, 4 times 3 is 12. Same signs. Add and keep the sign. That'll be a -42. Then I'm going to do dx. So for dx, this first column, this x column, is replaced with the constants 12 and 24. The second column still stays the y coefficients. And we put our bars on that, and then we calculate. So we're going to do 12 times -6 is -72 minus 4 times 24 is 96. So again, we have same signs. We're going to add and keep the sign. It's going to be -168. Now we're ready for dy. So the x column goes back to 5, 3. And now the y column takes the constants 12 and 24. Straight bars. And we're ready to calculate. 5 times 24 is 120. Minus 12 times 3 is 36. And that's going to give us 84. Sometimes the numbers get kind of big. Not always. Okay, but just because you get big numbers doesn't mean you're wrong. So the next step is to find x and y. So x is dx divided by d. Actually, I'm going to come over here. X is dx divided by d. So that means x is negative 168 divided by negative 42. You've got a negative divided by negative is positive, and 42 goes into 168 4 times. So that's our answer for x. X is 4. And then we're going to do y. We find y by taking dy divided by d. So let's see, dy is 84 divided by negative 42. And the result of that would be negative 2. So now we have our answer for x and y. We're going to write our solution as an ordered pair, 4, negative 2. And certainly you can check it just like you can with any method. If you take those values, plug them back into each one of your original equations, both equations should be true when you substitute these values in. It doesn't take long to check. You can use your calculator if you want, but I would definitely recommend checking your answer. Okay, so we've learned how to do one. Let's go ahead and do another just for the practice. When we start, we do want x and y on the same side, constant on the other side. Same way we would want them to be if we were solving by the addition method. So here I'm going to leave the 3x on the left. Let's see if we want to go to the side, or I guess we'll come out here to the side. 3x, we're going to subtract the 7y, and we'll leave the 1 on the right. And then here we've got 2x, we'll subtract the 3y, and then it'll be a negative 1 on the right. Okay, so now we're ready to set up our determinants. We're going to start with D, and we do x coefficients, 3, 2, y coefficients, negative 7, negative 3. And let's calculate that. Start at the upper left, multiply the diagonal, 3 times negative 3, and then minus, multiply your other diagonal, is a negative 14. So negative 9 minus negative 14 is same as negative 9 plus 14, so that's 5. Okay, now for dx. Replace the x column with the constants, 1 and negative 1. And the y column stays, negative 7, negative 3. Now remember, we're looking at these new equations, not the original, okay? So the negative signs have to be on the 7 and the 3 for this to work. Okay, start in the upper left, 1 times negative 3, minus, and then we go the other way, negative 7 times negative 1 is 7. So the result of that is negative 10. And then dy. So x is back to 3, 2, and the y column gets the constants, 1, negative 1. Okay, starting in the upper left, 3 times negative 1, then it's a minus sign, and 1 times 2 gives us a negative 5. Now we are ready to find x and y. We'll start with x, and we're going to take dx divided by d. So that's going to be negative 10 divided by 5. So x is negative 2. And now let's find y. dy divided by d. So that's going to be negative 5 divided by 5. So y is negative 1. Now it is possible to get fractions on these, by the way. So if you get a number that's not divisible and you end up with a fraction for your variable, doesn't necessarily mean you're wrong, but again, I would always check your answers back in your original equations. So let's see, our ordered pair is -2, -1. So that's how you use Cramer's rule to solve a system of two linear equations. We can also use it to solve a system of three equations. It's a little more involved, a little more calculation. So I'm going to stop the video here, and I want you to go ahead and practice just the 2x2 determinants and using Cramer's rule for two equations. And then I'll make a second video for a 3x3 determinant.